Okay, cool. We got a thumbs up. I swear I'm not gonna do this all day. Um, so, salutations, Astro Explorers. I am Ambericent Cornett, your host for today's exploration in the STEAM Speaker Series, brought to you by AWIS DC and sponsored by Camilico LLC. As the president-elect of AWIS DC chapter, I bring over 22 years of experience spanning federal service, financial, and public health sectors. I'm also an intelligence and information operations and cybersecurity expert, currently within the dissertation stage of my quantum technology doctorate. So, yay, go me. Um, so, of course, all of that winds up into my repertoire of why I'm the host and why I'm pretty prevalent on most of these cases because I bring people on here that I can actually, vocalize and conversate with. So here we go. My work includes significant stints in engineering program management and space medicine epidemiology at Johnson Space Center at NASA and rightfully in my hometown of Houston, Texas, as well as global migration and zoonotic infectious disease epidemiology with the CDC. So today's session continues our tradition of showcasing the diverse talents within STEM, which is science, technology, engineering, arts, and mathematics, and we are including medicine as well. Our speakers, both emerging professionals and esteemed experts, hail from across the globe, highlighting our commitment to celebrating women's achievements in these fields worldwide. It's a privilege to introduce a distinguished guest and a dear friend of mine, Miss Ruth Nichols, who has background in innovative research, and she has a background in astrobiology and applied mathematics, and continues to captivate and inspire. Let's delve right into her remarkable journey and insights thus far. So Ruth Nichols is graduated magna cum laude with a dual Bachelor of Science in Astrobiology and Mathematical Sciences from the Florida Institute of Technology. As a fact, this May 2024, she completed her study. So congratulations, Ruth, on that amazing feat. It's awesome. Um, which brings her here to talk to us. So she is a member of the Beta 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 Biology Honor Society, the Sigma Pi Sigma Physics Honor Society, and the Phi Kappa Phi General Honor Society. She is also a 2022 and 2023 astronaut scholar. You heard me right, an astronaut scholar. And she is also a 2023 Z Factor Fellow and was selected for the NSF Graduate Research Fellowship and the Schwarzman Scholarship. While at Florida Tech, she has done a surmountable amount of research on quantum bioenergetics, astrobiology, and mathematics, and growing plants in space conditions. In 2023, she commanded an analog astronaut mission at the Inflatable Lunar Martian Analog Habitat, or for short, ILMAH, in North Dakota, and made an educational documentary about this actual mission. So we will make sure that we get that to you at the end of this, and we'll put it in the description so that anybody that is interested in this in the documentary can definitely follow up and reach out to Miss Ruth as well. She has completed an aerospace policy internship with the Aerospace Industries Association, and she wrote about the McGraw-Hill education, Science is for You, and local Florida news outlets, and has given talks for organizations such as NASA Kennedy Space Center, Visitor Complex, and the Ministry for Space Education. So if you don't know anything about NASA, one of the locations, the launch in Cape Canaveral is actually in Florida, Kennedy Space Center. So just kind of pinpoint where we are on the map. Ruth is a scientist astronaut candidate through the International Institute for Astronautical Sciences, and a researcher, analog astronaut, and science communicator from Texas. So she is actually calling us on Central Standard Time right now, if you don't know. So so we are kicking back a couple of time zones for Miss Ruth to be here. So we appreciate you absolutely. Thank you so much for being on our program and being one of our esteemed guests. To the audience that is in love with STEM and all things STEM. So welcome our astrobiology ace and math maven. Can't forget about math. Miss Ruth, how are you today?
I'm doing good. Yeah, I'm really happy to be here. How are you doing?
I'm awesome. And as long as I don't get to, I told her before this started that I'm all day I've been getting tongue tied. So hopefully that does not occur. That'll be like the internal joke for the STEAM speaker series that I can actually mess this up every now and again. So um so I mean hearing all of that you have accomplished thus far, that's a crazy amount. I mean, I can't even imagine. I spent some time at NASA and Johnson Space Center, and just looking at the program for the astronaut office and their buildup for their just them working towards being a level of aptitude to go into space for the actual astronaut corps for the expeditions is crazy. So I can only imagine the train up and everything that you've done in your work for this analog astronaut program. So kudos to you, because that is a thing that a lot of people just cannot do. It's strenuous to say the least. But this is the perfect equation, having you here with us today, Ruth, to share your expertise and passion and your innovative research that you've been conducting as an astrobiologist and applied mathematician. We have a lot to explore here because we want to really dive deep into how you know, devised this plan to do both astrobiology and mathematics. Is I mean, as if one is not crazy enough. You just had to throw in a second one, just a curveball. Um, so we want to talk to you, and I'm confident that our audience will be inspired to delve deeper into the fascinating worlds of space biology and mathematical models. So. Um, for the audience, just to let you know, if we do find anything that we might want to clarify, we will clarify any acronyms or terms, technical terms that may come up in this segment to ensure everyone is maintaining on the X and Y axis. That's a math thing for you. Um, so, Ruth, could you start by explaining what astrobiology is?
Yeah, of course. So astrobiology itself is a very new field, but also a really big and growing field. And it kind of encompasses a lot of deep questions about life in the extremes in general. But I like to kind of group it into three main questions or a couple of main questions. And one of them is, how did life start on Earth? Which can include looking at the fossil record and the history of life on Earth, and also understanding how could life start on other planets or other places in the universe also. Then another question is looking at just trying to find life in the universe. How does life start? Then the other one is kind of, where are we going? How can we go into space, which can include studying astronauts, or how do we grow plants in space, and how can we live on different environments in space. So I think those are some big questions in astrobiology, but overall, it's a lot about studying life in the extreme. I like to describe it.
I mean, perfect explanation. I couldn't have thought of it better. I can't because I'm not an astrobiologist, but you are. So we come to you for these answers. Um, and I hope that that clears up astrobiology as a whole. We can kind of dive into mathematics as well, but I mean, that's just kind of general knowledge, right? So let's go ahead and do a little bit of an introduction into astrobiology and mathematics. So, Ruth, could you start by telling us what drew you to the fields of astrobiology and applied mathematics, and how these disciplines intersect in your studies? Because most people know some science is just not there without the math. So go ahead and
Yeah, exactly. I think for me, I was always interested in biology. Since I was younger, I always liked animals. I also liked dinosaurs. I still like dinosaurs, of course. But then going into high school was when I started learning more about microbiology and cells and the biology that is not so visible by the eye. And so I always knew I was interested in biology, but how I heard about astrobiology, I actually did fencing, sword fighting as a hobby in high school. And my fencing
Okay.
instructor, yeah, it's a little untraditional way to learn about astrobiology, but my fencing instructor was a physicist. And he would give me a lot of books and videos about science, and a lot of them were about astrobiology. So that's how I first heard about it. And yeah, I was drawn to it because I feel like it focuses on some of the biggest questions we have, kind of about life, science, but especially biology. So I was very drawn to it. And then as for the mathematics, I think it's really interesting. I've also just kind of been drawn to it, that way of thinking, and I find that's just prevalent throughout everything. I think that it can help solve so many different problems, that mathematical modeling is very important. Um, and in high school, I started taking AP Calculus 1 my freshman year of high school. So just took a lot of
Yeah.
math in high school, and wanted to study that more. So yeah, I guess that's how I got to where I am today, studying those two fields. And I do think that they intersect in a lot of different ways. I've done some research combining the two, and that's like there's the famous Drake equation, which is a mathematical equation to try to find the probability of finding intelligent life in the universe. So I think there's a lot of intersections, specifically with the probability of life on different planets or in space in general,
Right.
or probability of finding fossils and so on. So yeah.
Yeah, I mean, and it's an unwavering distance between, like, you can't have one without the other. And I think that a lot of individuals that go into science just say, okay, well, I'm done with math, I'm good, I can throw it all to the side. And unfortunately, I'm sad to say, audience, that is just not the that is just not the case. We have to have it. Most of the astronauts and most of the engineers at NASA, especially at Johnson Space Center, when they were looking at sending individuals to space, it was a lot of calculations involved. And if you don't know, Hidden Figures will definitely tell you like a big chunk of that entire model of getting people to space and actually having the rocket launch and everything else, from the trajectory, the analytics, all the data that went into it, mission control, and all everything, like everything touches math. So sad to say, if you go into science, you're gonna have to be at least a little bit decent with math. So awesome that you took it hand in hand for sure. Um, so how do you apply, being in the field that you're in? How do you apply mathematical models to solving problems in astrobiology?
Yeah, so I have specifically been working on this one research project to combine the two. I've been working on it for about a year, and we recently submitted a paper to the journal Astrobiology, which is one of the top journals in the field, and hoping it'll get published pretty soon. And I presented it at a few conferences, but yeah, basically it's about probability again, but specifically trying to use mathematics and this concept called Bayesian analysis and Bayes' theorem
Mhm.
to find the probability that we even happened on Earth. What's the probability of life having happened in early Earth conditions? And we
Right.
get a range of different values considering, because there's a lot we don't know about early Earth. So we put input into our model different numbers of places where life is able to happen on early Earth. How many times did it happen? And other factors that give us kind of, we're pretty 95% confident of these intervals of how likely life might be on Earth. So that's one instance, one that I've been focusing on a lot. But there's also many other ways you can do it as well.
Okay. Well, I mean, hey, look, as an advocate of always promoting things, even in the aftermath of, guests being on here, when you publish it, let me know and I will add it as a note in the description and say, hey, that article that she mentioned about being in the journal has finally published, because we're definitely leaning on the side of publishing. But once it publishes, yeah, we'd love to read it and just say, hey, I know that lady. She was on the Stone Seeker series and she has an article in this amazing astrobiology journal. So, yes, please keep us posted on that. So, okay, well, what specific area of astrobiology are you most passionate about and why?
Yeah, so I guess, like I mentioned, astrobiology is really big, has a lot of very broad questions with so many answers to be found. But I think for me, I'm very interested in space biology, which is very similar to astrobiology, but focuses a lot on the where are we going questions. So the studying astronauts, studying microorganisms, studying plants in space conditions, how they can survive in these conditions, how microgravity, radiation, isolation affects living organisms. But specifically, I'm very interested in growing plants in space as well. So space agriculture, space plant sciences. And I guess that's because I've done a lot of research on that. So
Right.
my research groups have kind of converted me to that group. And so, yeah, that's what I'm most interested in.
Okay. Yeah, and I know this might be a little bit off topic, but do you recall any other, I guess, areas of astrobiology just in case somebody might not be interested in just plants? Maybe they might be interested in something else. I know this is caught
All
off
right, yeah.
guard. I'm sorry.
No, no, plenty of other things in astrobiology that I can just talk about. Um, I guess another thing that I'm really interested in are extremophiles. So those are any type of living thing that thrives and really enjoys living in some type of extreme environment. Like there are these small living things that like to live in battery acid. They eat battery acid. There's things at the very depths of the ocean where the pressure is really high and the temperature is really low. So I think studying those is really interesting, and that can be so many different environments too, like volcanoes, the ocean. There's a lot of what we call analog habitats on Earth that resemble habitats on other planets. Like the Utah desert looks a lot like Mars. So you can go to the Utah desert and study the life there to try to understand life on Mars. So that's another topic that I'm very interested in.
Okay, and then just to kind of let me pivot real quick because I have another question, and I hate I'm doing this to you. But analog astronaut, what is the difference between an analog astronaut and an astronaut that goes actually into space exploration or space exploratory science? What's the difference between the two so that the audience can kind of get a good grasp on the different types of astronauts?
Yeah, that's a great question. Important distinction. So I did mention analog habitat, so some type of habitat on Earth that resembles something you'd find in space on another planet. So we have several of those on Earth. Some of them are natural, like the Utah desert. Some of them are man-made that are supposed to replicate space stations or space habitats on Earth. And as an analog astronaut, you don't go into space necessarily, but you stay at an analog habitat or analog site for a period of time. And the biggest component of that is being isolated from the outside world. And you simulate being in space, but not actually being in space. And these are very beneficial to train future astronauts and to test out equipment, to do research on isolation before going into space. So it's in preparation and it's less expensive, more accessible. Yeah.
Yeah, and I mean that makes perfect sense because I mean a lot of people may have that little bit of a like an internal, not really exploited fear of going into the unknown, the abyss of space and things like that, but they still want to get involved in some type of astrobiological study or do something related to astronaut support. And they may not feel like, hey, you know what? I don't want to go into space. I feel like it's a little outside of my league. I'm not, I'm adventurous, but I'm not that adventurous.
Mhm.
So let me stay in the confines of, the negative 9.8 forces of Earth and let me try to benefit science in some other way. So if you're looking for astronaut development and things like that, analog astronaut is definitely the way to go, especially when Ruth is backing all of the projects. So I'm hyping everybody that comes to this panel. I swear I hype them up. So if you have questions about the passion behind astronaut discovery and things like that, but you want to involve yourself in some type of analog astronaut program, I'm sure Ruth would love to talk to you offline about it. So audience, please stick around and get more information on how you can contact this amazing woman. So let's go to some of your undergraduate research experience. You've been actively involved in significant undergraduate research, way more than I think I was when I was an undergrad. I think I did more of all the things that you did in undergrad in my grad programs. So, can
Mhm.
you share some of your insights about your current projects and what you've found most challenging and rewarding in your research endeavors, just thus far? Because I'm sure some other things are coming up.
So I talked a little bit about the mathematics astrobiology research project, but I have been involved with a couple of others as well while I was at Florida Tech. I think I was a freshman or maybe a sophomore when I joined the Usman lab for quantum biology. And his big question was studying how changes at the quantum level can change the cell at, well, the cellular level, and how it can change its use of energy and its activity. So a lot of what I did was working with cells, preparing cell cultures. I also built a 3D printer to do bioprinting to make these scaffolds to put our cells into, and just helped with kind of setting up the experiments, also writing a few articles about biomaterials, which are example materials that you'd use for transplants or to put cells in that biodegrade and that are biocompatible. So that was kind of what I did in that lab. And then I think the next year after that, also joins the Palmer Lab of Chemical Ecology and Astrobiology. And that's when I got a lot into space agriculture research.
Okay.
So the first project I did was the Project Red House, or the Heinz Mars Ketchup Project, which was a
Right.
very fun project. Um, and then I also did another project studying roots in plants and this behavior in plants known as kin recognition, where
Mhm.
plants are able to tell through chemical signaling in the soil how related they are to plants grow next to them. And our hypothesis is that they'll change their growth depending on how related they are. We think that if they're less related, they'll want to compete and they'll grow more to hoard more resources. And this could be a potential
Right.
technique for growing plants, especially in like Mars or on the moon where soil content does not have nutrients and so on. Um, and also that also involved a lot of mathematics as well when I did root analysis and going through our data to make plots and to kind of show what our data is saying. So that's some of the research that I've been doing lately.
Yeah, I mean that makes sense, especially when you're thinking about like the composition of soil on other, planets and things like that. You want to know whether or not one plant will actually literally excavate all of the sourcing in that soil versus
Right.
something that might not take so much of the nutrients out. And now you have the stress of all the other, plants around you
Mm,
that just don't
right.
thrive and this one plant does. So yeah, I mean, look, agriculture is very prominent in astrobiology for sure. Um, so let's talk about okay. Well, let's go into can you describe a particular research breakthrough or like one of those aha moments that you've experienced in your research thus far?
Yeah, I think with my experiences, there have been lots of challenges, but also lots of opportunities, lots of achievements as well. And I think one instance was with the kin recognition project I just mentioned. It was a big project with, hundreds of images of these plants to analyze. And if one thing was wrong, we'd have to start everything over. So it
Oh
was a
no.
very, yeah. It was a difficult but I think a big thing is if you don't know what's going on, that just means doing this research is more worthwhile to try to figure out this phenomenon. But I think one of the biggest things we found out was about the relationship between that behavior and the amount of nutrients available. So we grew these plants in different levels of nutrients, and the ones that grew in less nutrients, this process basically broke down. They didn't care how related they were to other plants. They would just grow and try to get as many resources as they could. So that was a
Right.
big thing we discovered, was how nutrients can kind of override programming in plants and their overall behavior. So I thought that was
Oh
very
man, okay.
interesting.
I mean, it sounds like a calculated model to say the least. And I don't know
Yeah.
if other people that have watched the program thus far have really recognized that like most of the sciences and most of STEAM in general feed into each other. Like last week or a couple of weeks ago, we had the quantum computing specialist on, and you mentioned quantum mechanics and quantum technology in the research that you were doing as a mathematician and astrobiologist. I mean, I didn't set this up. I swear to you, audience, it was not a setup. But it's really funny how you would talk about things like that, even though that doesn't really touch the realm of technology. You're still using inferences of technology into your, capabilities for astrobiology. And I think that's crazy how everything is kind of intertwined. So hopefully the audience kind of caught that. If you didn't, it's okay. I'll forgive you. But now you have to, make it up to me and go back and watch the other shows. So, all right. So, how do you balance rigorous, over demanding research demands with your coursework and other commitments? I mean, coursework is probably out the door now because you're done, but I won't spill the beans, but you do have other things that are coming up. So, how do you balance all of these commitments? Just being in all of these engagements.
Yeah, I think that's the big question, and I still try to figure out the answer to it. Um, but I think it's a process, and that over time you just get better and better at it. And for me, I think a big thing is I definitely try to put my academics first. So yeah, I just grew up thinking I need to do my classwork first, need to do my homework and so on, and then from there I'll sign up on my schedule. I'll sign up for what I can, and then usually I'll cut from there. I usually overshoot the time I have, but thankfully I've been in a lot of, and I would think that most researchers you work with or clubs you work with are very understanding if you don't have the time. So if you're working with them and then you realize this doesn't work, you can just communicate that with them, and they're usually very flexible. So that has helped me a lot with balancing everything, just trying to find what time I have for everything, prioritizing, of course, classwork, and then everything else after that. I think that's the biggest thing, is communicate with um, people in these different groups. And you can definitely sign up for things, but then after time, assess how much time you really have after signing up for your classes and clubs, research, and so on.
Yeah, I heard two very powerful words in that explanation, and that is prioritization and communication. And once those are in alignment, everything else is a free, reign. Because I mean, you think about like what your purpose is and what your drive is, what your focus is. That's your prioritizing, right? You're listing all the things that you want in an objective form, like, hey, these are my objectives for the day. That's my prioritizing. And then
Right.
of course the communication, you have to talk to people and say, look, this is on my list of things to do. I can only allot this much time
Right.
to this situation. I can only yield for this long so that I can make sure all of my other things manifest and are prosperous in the situation. So, like, I hope that that's a takeaway for the audience for sure. Communication, prioritization. That, like, best answer I've heard so far. Best answer. So let's talk about In fact, if we want to talk about communication, science communication efforts. So, so great segue. Um, you are a passionate and very meticulous and very pronounced scientific communicator. So what motivates you to share science with a wider audience? Because you could just keep it in your bubble and just keep it moving, but you don't. And could you highlight a piece of work that you are particularly proud of that you always probably bring up in a conversation, such as this or any other random conversation that you might have?
Yeah, so I think that for me, I guess I always grew up I was very interested in science, but I didn't feel like there were many resources, or it wasn't very easy and accessible to find those resources or to find mentors and so on to help guide me into this career. So growing up now, I kind of want to be that person for others. Um,
Please do.
so so that's the big why for me. And also, besides just that purpose in trying to do science communication and outreach, I think it's also just a very creative outlet. I think that science itself is creative, but combining it also with either writing or art or filmmaking, photography, I think is just such a
Yeah,
wonderful thing. It's very fun, and I think helps make science more accessible and comprehensible for so many different people. So that's some reasons why I'm really drawn to science communication. I think it's so important. And I guess we already mentioned it, but I'm very proud of the documentary I made about the analog mission. And again, would love to share with you all. But I think I'm very proud of that because it was kind of a challenge for me, kind of stepping out of my comfort zone. I'm very much an amateur at making videos, making films. So it was a lot of, I like went to the film club at my college and rented out a camera from the library and to try to learn from other students as much as I can. So I'm really proud of myself for doing that. And it was a very fun experience for sure. And I think videos are also just a great, you can see it, you can hear it. I feel like it touches all the
right, right.
senses.
Yeah, and I mean to get don't I mean it looks like I'm over here doing my very best, but I mean the speaker series is essentially just that. Like it's almost like your documentary where, novice coming into this situation and just trying to make the best I can and make sure that I reach as much of a, mass audience as possible, especially talking to people like you that, afford me the opportunity to bug you for about an hour or two and have this conversation and try to, make it fun and energetic and try to communicate that effort of like, hey, we're in science because we actually like it. We didn't get into science because we needed something to do. We have a innate passion and like an hilarious circumstance to just be in this field. So, I mean, we're not going anywhere. So, obviously, we want to pass on the torch to someone else, but we definitely want to,
Mhm.
invoke that type of commitment. Like, hey, we might be novice at filmmaking, but we're going to try to make it work. So, I applaud you, and I can't wait to see everything. And I'm going to make sure that I get that information and put it in the description for everybody. Um, so, what platforms do you find the most effective for engaging with an audience, and why do you think?
Yeah, I guess I already talked a little bit about video, about how I feel like you get you get to learn through seeing it, through hearing it, to just kind of almost experiencing it, except this screen as a barrier almost. So I'm very much a fan of video. I liked going to the museum to see the movies there. I guess I just kind of grew up with that. But besides that, um, I think that they're all important, that people learn in different ways and prefer to appreciate different forms of art, whether it's writing, whether it's art, visual art. So I personally prefer video, but I think that they're also important.
Yeah, absolutely. Especially when going through like science classes, I'm you can tell me how a cell is made up, but until I see it, I can't mentally picture it. It just something about the artistry behind it that makes it that much more vivid and realistic. So absolutely. Um, so how do you tackle complex scientific topics to make them accessible and engaging for general public, especially being in astrobiology, one of the newer forms that not a lot of people might gravitate towards when they're looking at STEM options?
Yeah, I think that can be challenging, especially if it's yeah, very unique, unfamiliar topics, somewhat foreign topics like astrobiology or especially like quantum mechanics, physics, space. I think that those can be difficult to break down. And I think one of my favorite ways is anecdotes and stories to try to make some type of tie-in to make this foreign
Right.
object more relatable and personable. So I'm a very big fan of anecdotes and stories, and also maybe personification or just trying to yeah, again, make it more relatable, whether it's yeah, using characters or kind of setting out a setting where this could take place. And so that's one of my favorite ways to try to break down a concept bit by bit.
Okay, cool. And I mean that the more the better for like, just the invitation of it all. I think that the visuality of it just makes for a better space for us. So we're going to talk about a little bit about analog astronaut experience, if you don't mind. As an analog astronaut, what kind of simulations have you participated in, and how do these experiences help prepare for future space missions? Because I'm assuming that you probably want to be an astronaut, like physically going into space. I won't put you on blast, but maybe you can submit this for your astronaut core evaluation, and let them know, like, hey, I've been talking about this forever, you should let me on the team. But how how do you how do those experiences help you prepare for, or help a person prepare for future space missions?
Yeah, so I about a year ago in yeah, I think it was May 2023, I commanded a 14-day analog mission at the Inflatable Lunar Martian Analog Habitat, or ILMA, at the University of North Dakota in Grand Forks, North Dakota. So this was for 14 days, and it was with me and two other women, and we were the first crew from Florida Tech to do this thing. We were the 15th crew to go to ILMA, but we were one of the first all-woman crew to go
Oh,
there.
nice.
So it was a very meaningful experience. And I think that, yeah, I think in itself, in preparing people for going into space, it being on Earth, it can't simulate microgravity or radiation per se.
Right.
But I think the biggest thing is isolation and also working with others, especially if you might not have privacy, and just working with people in close quarters for an extended period of time. Think those are some of the biggest things that you learn from being in an analog mission. But also, I think it can be a lot about challenging yourself and a lot of personal growth from working with others and learning how you work under stress. Because I would say that most people are at some level of stress just by being in an analog habitat. Um, so I think that you can get a lot out of it, and that it really helps people prepare for namely isolation and working with people.
Okay. And then I know I should not be pivoting, but I will, because I feel like this is informational too. As far as your analog astronaut confines, can you describe the mission, like the overall mission itself? Like where were you? How did it look? How did it feel? What was the adjusting that you had to do for that 14 days? Like what was your environment? And then second part is, what suits or like what type of uniforms or anything like that did you have to wear, if you could describe both of those?
Yeah, I would love to. This is what I like to talk about when I give talks at Kennedy and so on. So I love talking about it. Yeah, so essentially we were in this simulated space habitat. It had different modules. We had a living module or living headquarters. We had a geology lab. We had a gym, and we had small bed spaces. We had a kitchen, living essentials. We also had a rover, which was a car that we could drive
Oh,
around to
nice.
look at where we are. And we also had the EVA module. So EVA stands for extravehicular activity, which is whenever you go outside of the space habitat, go into space. So one of the most my favorite part of the analog mission was doing EVAs. So we did have one of the benefits of ILMA and being at the University of North Dakota is there they have the Human Spaceflight Lab where they make a lot of spacesuits. So
Okay.
we didn't wear actual spacesuits, but very accurate mock-up spacesuits. Um, and so they weren't completely enclosed. There was, I think, like a hole for oxygen circulation for safety reasons. They weren't pressurized, but they look and felt like the real thing. Um,
Right.
and
That is
getting into
awesome.
them, thank you. Yeah, and getting into them was very difficult. They take the Russian spacesuit method where you crawl in through the back through like a wall. And you have to have two other people help you get in. So they're big, heavy, and hard to walk around in. So part of another big thing is of why doing analog missions is to test these spacesuits, and to have people walk around in them. So yeah, these were pretty close to the real thing. Um, and besides doing EVAs, on our EVAs, we would collect samples and practice using equipment that you'd use on an EVA. Like we used this one tool to grab samples that was actually based on blueprints at Kennedy from the Apollo program. So it was very exciting to actually have that in your hands and use it. And besides doing EVAs, we also did a lot of research. One experiment was the cardio breath experiment, where we'd have a bunch of sensors to collect a lot of biological, physiological data about ourselves as we did these exercises. And then we'd do this at different periods of the mission. And then they would compare that to astronauts on the ISS to see
Okay.
if isolation affects your health. Um, and also did other experiments about how we were able to focus throughout the mission. We grew a lot of crops. So there's a lot of research, a lot of testing equipment, and also was doing a lot of filming. So, and yeah, it was very isolated. We couldn't really call or talk with family, no internet, social media. We can only communicate with a simulated mission control through, and our communication platform with them had a 20-minute time delay to simulate being on Mars.
Oh,
So it'd
wow.
be like 40 minutes before you get a response from your questions. So it was very um, realistic experience and very meaningful experience for sure.
Well, you just counted out like half of America that wants to do any kind of astrobiological studies. Because as soon as you said no social media, I'm sure that everybody started tuning us out.
Yeah.
Like, but I don't know if like the audience kind of caught at the beginning, but I worked at Johnson Space Center with the astronauts and I worked ISS missions and all the other missions. We kind of did epidemiological studies and compared them to the astronaut offices of today, which is all the ones that go on the expeditions, and I forget what number we're on now. I've been away from there for a while, but I'm looking for the resonance of what you're doing in analog and what they're doing in their mission. So like the EVA is very similar where you actually have to get into the extraterrestrial suits and have somebody help you. So that teamwork plays a big part too. Like that's why you had three people on the mission and not just one, like the Martian. So, and you know what I'm talking about, right? Like the moving
Yeah.
with, okay.
Yeah.
So a lot of that literally replicates what they do in space. The only difference is the G forces and gravity here and
Mhm.
everything like that. The oxygen manifold that you said that is on the side for the safety precaution. And of course, they'd have the tanks for extra vehicular
Right.
activity outside for the astronauts. And then, of course, what's the other thing that you mentioned? Oh, I wanted to ask you about robotics because I know that robotics is a big thing for EVAs and things internally for the ISS. So, did y'all have any interaction with robotics or just some of the pieces that were for the Apollo mission?
Mostly just the pieces from the Apollo mission, although I think a lot of other missions have used like automated rovers to simulate
Yeah.
controlling a rover. And one of my crewmates, not necessarily robotics, but she was doing research on how to make an automated greenhouse. And one of we had a mini container called the Exolab, which was a small automated greenhouse that you just didn't need to touch. It'd take pictures on its own, feed itself
Oh,
essentially.
wow.
And they had similar one on the ISS. So again, it
Yeah,
was
yeah,
to
yeah.
compare the two. So there was a
Yeah,
few.
and I was gonna mention that. I was like, okay, so y'all use some of the stuff that we're actually using. So if you, again, if the audience is interested in doing analog space program, this is one of your opportunities to not put yourself into the droves of crazy space exploration, but be here on Earth and be a little more non-compartmentalized. Because I mean, you go out into space and then you have all of the issues that could happen and things like that. But here, it's a little bit more controlled, and environmental stability is definitely there. So, okay, cool. So, I mean, I know we pivoted, and that was not one of the main concepts, but I definitely wanted to talk about like the actual mission and to see if y'all did EVA the same kind of way and things like that. And because y'all had a rover, that's pretty indicative of space, reenactment also. So I really love that. Um, did y'all do any mock-up training exercises before that? Because like we have the National Buoyancy Lab, which is NBA or NBL down in NASA Johnson Space Center. So we have this big, huge, aqua mechanics tank where they actually have all the underwater equipment so that they can simulate space action before actually going up into space. And it's essentially scuba divers and some other people that go down and help you like fit yourself into the suit, do some, hour-long training sessions and things like that. Did y'all have anything mock-up related that was dealing with actual train up in order to get to the astronaut analog course, or did you not have it and y'all just jumped into the course?
For the mission start to have training during those days. So during that training, it was mostly to practice everything we would do in the habitat, but with people there on site with us to show us how to do it. The biggest thing was getting into the spacesuits and practicing walking around so that then we can do it by ourselves while in the habitat. So that was one of the biggest things in practicing driving the rover around. And also another big thing during that time was getting all of our food reserves for 14 days. That
Okay.
took a lot of time in coordination, and also talking about how to communicate with mission control, how to use the radio comms, and also talking about here are the med kits, basic medical emergency preparedness, and also just best practices for communication, team effort. So nothing as cool as MBL, but we did get some training beforehand.
But it's still similar, so that it does replicate. The only difference was water. So, and that's fine with me, right? And then one more question about the food topic, because you brought that up. Did you all use freeze dried food and things that were vacuum sealed, or did y'all actually collect real live food that you could refrigerate and things like that? Because you have 14 days. So how was that? Was that different from, because we do missions where we actually have all of our stuff preserved and heavily preserved. So did y'all deal with preservatives, or did y'all use all fresh based food items?
Yeah, for us, we did have a few. We had like a fridge and we had a big ice storage. So we were able to keep some food there. We really liked getting like frozen food, like frozen vegetables and fruits. So we got a lot of that. Um, I think we got just a very small amount of shelf food. Like we got some bread and bananas, just knowing we have to eat that first. We can't
Right,
let that
right.
wait. And I think most of what we got was pre-packaged or iced. We did not try the like food preserved foods, but I do think that's there's a lot of interest in that, and that a lot of other analog missions do use that. But we had the fridge and the ice cooler, so we used that.
Okay. Okay. So y'all had the glamping style instead of like the dried mashed potatoes that you have to add water to. Okay, so that's awesome. So at least the food factor was a little bit more palatable than space flight for sure. Um, So, so we'll pivot right back to the original kind of like Q&A. What are some of the unexpected challenges that you faced during the simulations that you've been involved in, whether it be you actually on ground or other people that you've helped to do the simulation process?
I think a big shock for me was just how isolated I felt. I thought that the isolation wouldn't get to me that much. You know, I've been inside for periods of time, but this was kind of different. We didn't have windows, and yeah, you really couldn't talk with other people. And although we could go out on EVAs, we'd be wearing the space suits, so you couldn't feel the breeze. Even though you could see the outside, it was almost like it was teasing you. You couldn't actually
Right.
be in the outside. Yeah. So that was a big thing for me. I was really missing rejoining civilization. And besides that, I also think was the work component of working with others. We didn't really have many problems with my mission, but um, I did notice that we were all kind of tense at times, and sometimes there'd be just overreacting to things, or yeah, just kind of all on edge. Although nothing bad happens, just how we respond to things was not how we naturally respond to things. So I think I was kind of surprised by that, and I learned a lot about how to work with others and to compromise, and just also how I act under stress. So I think those were some surprising things for me.
Yeah, and I mean, just to kind of like caveat and give the audience some a little bit of a perspective. Um, Missions like analog astronaut circumstances are definitely very altered because of the lack of sources of reality. So we seen a little bit of that kind of concept when we did, like, of course, COVID. I hate to bring this up, but COVID was a little bit of a taste of an analog approach, because for a while human interaction was very limited. In analog studies, it's completely limited. It's just the people that are involved in the mission and the support of it all. But in COVID, we had, internet and things like that, and some of the interactions between people that would drop off our food and delivery services, things like that. But then if you think of like space and the opportunity of being in the ISS, it's what, a max of 6 people at a time, and that's the only interaction you have. Cultural differences play a big part. You can't really pick who you are involved in this space frontier with. But then also, one of the things that people don't know is that you do a lot of psychological evaluations while you're in space. So, like, yes, you have your regular normal checkups with your space surgeon, which is basically your physician, your PCP, if you want to call it that. And then you also have a different interaction where it's completely by you and your psychologist at the time, your space psychologist, that you have these interactions just to gauge the merit of, circumstances based on your psychological approach to space and that space flight endeavor. So I don't know if people really kind of got that gauge, but between space flight and like the COVID-19 situation that you probably endured, and analog missions and things like that, they all kind of have their own psychological balance to them, and that kind of like gives you a little bit of a source of how astronauts can kind of feel a little bit of isolation and a psychological, perception of it all. So good. I love that. So, okay. One more question before we take it to a little bit of a break. How has being an analog astronaut influenced your perspective of real space missions, aside from what I just told you? Because you can use it if you want to, but aside from what I just told you, how has it influence your perspective?
Yeah, again, I guess we couldn't test like microgravity effects or radiation effects, but I think the big thing is isolation effects. And that's going to be really important when studying how people go into space and what can happen to them, and preparing for going into space. That
Yeah.
isolation and how you work with others can be really important. And I felt like I didn't see how significant it can be. So I felt like this mission just highlighted that we need to do more analog missions and more preparation on topics such as this. And Yeah, like you were talking about, there's a lot of similarities, but there are also a few differences. And I
Right.
think analog missions could be improved, and that there's still a lot to be known when preparing for space. But yeah, I think that these are very important and meaningful experiences, whether it's to introduce someone to a STEM or to really test out equipment and prepare for going into space.
Yeah, and I mean, we talked a lot about like the astrobiology concept of everything, but this is another off scale. I hate to do this to you, but I have to because it just makes more, more realistic interaction. So mathematically, how was it with the mathematical approach in the analog astronaut system or circumstance? Like how did you use math on a day-to-day basis?
Yeah, I guess a lot of, to be honest, a lot of the every day was just very, very busy and somewhat hectic because there's every hour you had some type of experiment or research you had to do. Like the cardio breath experiment would take a long time. You have to remember to water the plants or check this and that. Mission control would give us tasks to do, like check the temperature in this room, or something would surprise would happen. The door isn't working or something. So it was very hard to find time to do things, but I think some of the crewmates did do, like I mentioned, one of them who was studying kind of automated agriculture and specifically controlling temperatures in agriculture, because one challenge we did have was the greenhouse module would overheat a lot. And what she was doing was modeling. She was modeling all of that. So not physically constructing it, but creating mathematical and computational models of these greenhouses. So that's a lot of what she did. And also, another crewmate was doing a lot of data processing for all these different experiments. And in particular, a lot of our neurological experiments. We had this headbands that would measure how much oxygen was going to our head when trying to like focus on something in front of us. Just to
Mm.
a measure of our ability to focus essentially or to think critically. So she did a lot of noise reduction and just data processing on that end. And I think I also try to assist with collecting and compiling all of this data into one place with all our different research. And then also just a lot of video editing also.
Yeah, and I think that a lot of and not calling anybody novice in the ideals of space exploration, but all through even the ISS missions and things like that, they were doing constant computation, constant evaluations for their circumstances. They were looking at mathematical models that they had over long duration during their space flight. They were actually doing medical evaluations. They were doing exercises. They were counting calories on a daily basis and sodium intake and things like that. Their nutritional values were being tracked. And they were also doing experimental, support for people that wanted to do an experiment while this one particular expedition was in flight, or over certain, lengths of expeditions, like maybe 30 through 40 or 30 through 50 would do the evaluations for these extended periods. So it's work. It's not just going up and floating around in space and eating blobs of water droplets or like analogs. You just go and have a big camping session. No, there's a lot of work that goes into it, and experiments for sure. So I just want to make sure that those similarities and differentiations are made so that people know, like, okay, one is not easier than the other. It's it's all hard work. So but it pays off, because I mean you get to do some amazing work, and then you can compare all of your stuff to the astronaut office. And I'm not gonna lie, we use astronaut analog data for some of the missions that I know I've been involved in. So yeah, your work has not been in vain at all. So I believe it is time to boldly go where no woman has gone before. I know it's a little bit of a Star Trek engagement, but feel free to take a stretch or stay put. We'll be back in a flash, just about 3 minutes away. So stay tuned. Good. Never mind. All right, so we can start back. Ruth, fellow arithmeticians, welcome back. Let's launch right back into our discussion about astrobiology, applied mathematics, and their pivotal roles in space exploration and beyond. So let's talk about this amazing Heinz Mars with a Z catch-up project. So you're involved in this intriguing Heinz Mars Edition catch-up project. What was the goal of creating the ketchup for Mars, and what have been some surprising aspects of this research that you want to just share with the audience?
Yeah, so this project, also called Project Red House, it ran for about 2 years, I think, and I think I joined in about the second year. And the goal was to grow over 400 tomato plants in in simulated Martian regolith, or simulated Martian dirt, Martian soil. And we got this regolith from Exolith Lab, which is a lab that creates all kinds of simulated regolith for Mars, for the moon, at the University of Central Florida. And then we grew a bunch of tomato plants in this building off campus. And there were a lot of challenges. It's very hard to grow plants in Mars conditions. And the biggest factor we were looking at was the content of the Martian dirt itself. So there was a lot of challenges with just trying to grow plants in that non-conducive dirt.
Right.
But also there was, we had water issues, or sometimes there'd be gnats, fungal infections in the plants. Just a lot of things happened. But in the end, we got a good enough yield, and One of the biggest accomplishments was this was the first time we actually showed that food from grown in such space conditions is edible and healthy for consumption. There have been many studies on how to grow plants in Martian regolith, but not if we can actually eat it. So this was
Oh,
a
wow.
big milestone in that, and it even passed, Heinz very rigorous standards for ketchup and tomatoes. Although the tomatoes, were much smaller and had a lot less sugar, but they were not toxic to humans. So it was a really big project, and it's technically still ongoing, but using the next generation of tomatoes from the original group of tomatoes.
Okay, so what you're telling me is that some ketchup bottle somewhere in this United States is probably Martian ketchup, is what you're telling me.
Yes,
Okay,
yep.
so perfect. So next time you look at a bottle of Heinz ketchup, look to see if there's a Martian, release form on the back or something like that that says this plant was grown on a simulated Mars, opportunity. So that's really cool, and I have not heard about anything edible, from Martian yield. So that's awesome. So just to kind of, and I hate to do it again, but I'm going to pivot because I know you know the answers. Um, the differentiation between Earth and our soil and composition. What are the compositions for Martian soil that you had to inflict this crazy mission on? Because I'm sure that I don't know. So I'm going to ask for, the betterment of myself. So what were the situation for the Mars soils that you were trying to produce the tomatoes?
Yeah, I guess the biggest thing about soil is, there's lots of microorganisms in it, lots of decomposers such as worms. So a lot of just it's its own ecosystem essentially that helps the plant grow, and those help the soil get rejuvenated essentially. And besides that, just lots of organics or carbon-based materials that help make up life. Lots of, we put fertilizer into our soil. So just all kind of the makeup you need ideally to grow plants based on what we know about plants. But on contrast, Mars doesn't really have any of that. It has some of these essential ingredients, but it also has a lot of toxic metals in particular, and lots of
Okay.
iron, for instance. But thankfully, this showed that even despite that composition, the plants can be healthy to eat and not harmful to humans. But I guess another thing to note that just by the nature of these simulants being made on Earth, they're probably going to have some type of life in them. It's hard to keep life. It's hard to have something perfectly sterilized. And
Right.
so likely there was something in it already, and that might have helped us with growing the tomatoes. So it's very hard to get, very completely 100% realistic Mars conditions on Earth. But still, it had mostly heavy metal content.
Okay. So, okay. Well, I mean, and that differentiation definitely explains the difference between like the farmers and the growing patterns here and, Martian activity. So, yeah, thank you for that explanation for sure. So what scientific principles are you applying in this particular project to adapt ketchup production for Martian conditions?
Yeah, so I think again the biggest component we're simulating is the regolith itself, but also we've kind of somewhat tried to keep it isolated. During the first year when they were pretty young, we did actually have this inflatable, somewhat habitat, almost simulating a space habitat, to also try to add in that isolation component that you would get, for instance, in analog missions. So those were kind of two main variables we were looking at in this experiment. Although we also had different varieties of tomato, over 400 tomato plants. And also, there are also different types of regular simulants they're based on different parts of Mars, although they should, in theory, be about the same. They have very small differences. So those were some of the variables at play in this science. And a lot of the day-to-day work was just maintaining those plants, but at the end of the day was sending it to Heinz for testing, but also testing if they're able to make future generations, and so on. So
So, and this is this is another pivot only because I I know like I know the aptitude, so I'm just gonna ask these questions. So because we're here with G level forces, we have gravity, we have the composite of air with the formation of water droplets and things like that. We have oxygen. Whereas on Mars, that is not the composition of the atmosphere there. Not, I mean, the pressures we can't kind of, fix here,
Right.
but we can simulate the gases and things like that in, I guess, like the greenhouse that you guys had it as a preserve model for Mars. Did y'all do anything to alter the gases that were relevant in Mars to the greenhouse that y'all were preparing this in? Like, was that any changes or anything, or did you just leave it in Mars soil, but Earth conditions with oxygen and all the other water droplets and things like that? How did that change?
Yeah, that's a really good question. I think um, to try to add in all of those different components of the Martian environment would give us somewhat more accurate, more interesting results, you could say. But in our study, we were just kind of pinpointing the effect of the regolith itself, but also maybe isolation. So that I think that it's very valuable to add in as many conditions as you can, but also I think we're just trying to pinpoint one variable. Which is the soil. So here we had
Okay,
it in Earth-like conditions, although I think follow-up
darn it.
studies should definitely consider that. I think that that's really important. That's so important for growing plants. So I think it's very essential to incorporate that into the environment. But the most we had was just controlled AC, from the building. So
Right. Then you can't put gas in the AC because then it circulates. We're not gonna do that. We're not gonna we're not gonna destroy half of Florida Tech. So okay, cool. So how do you oh my gosh, how do you envision the future of food production in space based on your work with this project?
yeah, so as I mentioned, this pilot study took about 2 years, um, and it's still ongoing with the next generation, the next project, and within those 2 years, all of us, it's been like a really big group of students as well as the Heinz team working on growing these plants, and there are lots of failures and lots of accomplishments. So it's really hard to grow plants in space essentially. And I think that there's a lot of value in researching that, but I think that we have a long way to go before this is commonly available, before you can actually go to Walmart and find this on the shelves,
Right.
essentially. Um, but I'm hoping that maybe it'll be faster and we'll learn more about how to optimize that growth, make it more sustainable and more effective, maybe get better yields and just overall better understands how these plants grow in these conditions to help us when going into space. But I also think they just help us better understand life on Earth as well. So that's what I think.
Yeah, absolutely. I mean, it probably would help farmers too because of the, desolate conditions of like some of the desert areas that we have here
Mhm.
in the US and even like in Africa. It might be changed for the better to learn some of these analog opportunities and push it towards like agricultural domains. So that's pretty cool. I like that. So let's pivot a little bit to fellowships and awards because I mean, as a scientist, you're looking for some type of monetary relief from the student, structure of, financial obligations for tuition and books and things like that. So we look towards fellowships and awards and scholarships and things like that. So um, let's talk about like your fellowships and awards. So how have fellowships and awards particularly in your situation, such as the astronaut scholar recognition, influenced your academic and professional journey?
Yeah, I think that these different programs, these fellowships, scholarships have been one of the most important things in my career. And I can't really put into words just how influential they've been in my life. I think it was about 2022. I was in Oregon for a research trip, and it was during the pandemic, and I was like quarantining,
Oh,
just like
in
sitting.
Oregon.
Yeah.
No offense, Oregon, but I mean,
Right. And just like sitting in my bed, and I got this email saying, "You got the astronaut scholarship award." And that was kind of the first time that I got a major recognition or major scholarship. And that was just so, I just remember that moment, like where I was, what I was doing. And after that, I think getting these recognitions is important, in that you'll get more, it opens up more opportunities, more scholarships down the road. And I would go on to get it the next year, as well as get the Z Factor Fellowship and get these other Honors College awards and other scholarships as well. And they've all just been so important to me. And I think you get so many different things out of them. For instance, with astronaut scholarship, one of my biggest benefits has been meeting so many different people. For one thing, I got to meet astronauts for the first time, which I never imagined I would meet an astronaut, but now I've been talking to several astronauts, but also industry professionals, science professionals, and other students around the country who are really bright, really talented, but also interested in what you're interested in. Um, Getting to network with them and also share your research in conferences with them, and just learn about different career at networking and career fairs, and even like going to special events such as the Astronaut Hall of Fame. I think it's just so
oh,
important, the memories and experiences you get from this. And also, I got to speak at NASA Kennedy Space Center a few times through the scholarship, as well as be on a few panels where I had a meaningful experience sharing with others, but also I think that helps me grow as a person as well. So I cannot say enough just how important these experiences are, and I highly encourage you all to seek these opportunities.
yeah, heck yeah. And I mean, I know I'm giving you homework, but your mission, should you choose to accept it, is to to give us, information on all of these scholar programs and things like that that you did pursue. I mean, because the hunger and the drive comes from getting one and then another one and then another one. So, I mean, there are people here that probably would be able to benefit as well from the same experiences, or, better yet, they can probably, give you some ideas of some other things that you can do when you're, progressing in your professional and educational circumstances. So, yeah, the trade-off is equal, but yeah, I would love to put information like some websites or something like that in the description for this, so that our subscribers and everybody that is looking at this will say, "Oh, well, she talked about this. It's in the the description box. Let me copy and paste it and go look at this and see if I'm interested, if I qualify, things like that." So that would be really awesome. So yeah, we'll definitely talk after this to see if we can get some the merriment of all of that. Um, so, what other awards or recognitions have significantly impacted your career path? I know you mentioned the astronaut scholar recognition, but what are some other ones that you could think of just off the top that really stand out?
Yeah, so another big one for me was the Z Factor Fellowship. So there
Hmm.
are different types of aerospace fellowships for undergrad students, like there's the Brooke Owens Fellowship, and then there's the Z Factor Fellowship. And I think also similar to astronaut scholarship, I benefited from meeting all of these different people, these different also fellows. And also we had this events where we all met, but also got to meet so many different professionals as well, kind of up close and personal, and ask them questions and introduce ourselves, which I think is not. It's a very rare and valuable opportunity to do that. We even got to meet the National Space Council and visit the White House. So that was another
Nice.
experience I never thought I'd have. So and besides that, that's when I did my internship in DC with the Aerospace Industries Association. And I should have mentioned this with the astronaut scholarship, but also mentorship. A lot of these
Oh
programs
yeah.
give you a mentor, So I've also really enjoyed having mentor relationships with different people and going through that journey with them. So I think Z Factor was definitely a big one for me. I also got some awards um, from my honors college at my university. I was junior of the year when I was a junior university wide, and got different honors recognitions, which I'm very thankful for. Joined some different honor societies. And I was also selected for the NSF Grad Research Fellowship and the Schwarzman Scholarship. So I think
Nice.
all of these are
Okay.
so important, and I'm very thankful for all of them.
Yeah, and I mean, there are students that come back and watch these, and things like National Science Foundation or NSF is one of the ones that she mentioned. They have several programs, not just for astronauts and aerospace dynamics, but all of STEM. So I'm taking on my own personal homework because I'm going to go back and go pull some of these as well. And if you don't know, there are other, scholarship opportunities and internships with a lot of these organizations that she's mentioned as well as NASA. NASA, they have so many, and they do them year round. It's not just summer. There's some in the fall and the spring as well. So I'll be sure to make sure I put that in the description as well, so people can some type of take a look at all of these things and see what they can possibly get into. And I think some of these programs are not just for undergrad, they're for grad as well. So if you are not, heavily magnified in like a actual position, and they allow you the ability to kind of break free for a little bit to do the internship, I say that it's a wonderful opportunity for people to do it, especially if you're interested in federal work or interested in going and exploring space and beyond, for sure. So thank you for mentioning that, because now we both have homework that we walked away from. I thought school was over for the semester. um, how important do you think such recognitions are for young scientists and researchers? I mean, we've already hinted on that, but just go ahead and just level the playing field. How are these important for researchers and scientists such as us and people that might come after you that hear this topic of discussion?
Yeah, I think I did kind of touch on this, but it's almost like a snowball effect that when you get
Hmm.
these, you get more doors open, more opportunities are
Right.
introduced to you. So I think that's a big component of it. And again, meeting people, just kind of everything that I was talking about. But also, I think just recognition itself is so valuable. Especially, I was mentioned previously, how science can be difficult and it can be rewarding. And so I think recognition is important to support both of those, to encourage people to continue and remind them that you're on the right path, and that this research is valuable, and to give you that attention that you need and that support, that framework that you need. So I think there's so many different benefits of these programs for scientists and researchers.
Yeah, and you mentioned that it's not easy. Science can be frustrating too. I've had a many a yield where my research just, crashed and burned. But I mean, it's not a reason to regret or, just
Mhm.
disconnect yourself from that research. I mean, you just found a way that it didn't work. So that's all about experimental value and the circumstances of being a scientist and being a discoverer. So I mean, if you don't find one way of doing it, don't give up. Keep going, and that's everything that is the aspiration of being a scientist and just a STEMologist, right? Um, so with that being said, let's talk about like advice for people that are aspiring to be STEAM students, whether it's science, technology, engineering, math, arts, or medicine. Um, what advice would you give to students who are considering a path in STEM fields, particularly those that are interested in the less traditional areas like astrobiology or some of the harder complexes like mathematical sciences?
Yeah, so I think it can be difficult to learn about what is out there and if there's way to combine these fields that may not seem to be related. So I think a big thing is trying to seek out people, and especially with scholarships and fellowships, that's a great way to do it by attending talks such as this. I think that's another great way to do it. There are lots of different avenues, or even just looking up on Google, how can I combine these two fields, or what is this? What is that? I think that there's a lot of different ways that you can do it, and one is not necessarily greater than the other. And sometimes you'll get a gold mine, I think. On another note, I think that's research we touched on is difficult, but also just the coursework itself is also can be difficult. So
Right.
that can be that I feel like that can deter a lot of students from going into STEM fields. And sometimes they're what they call weeding out classes, where professors can be strict on you, and it's just very, very difficult classes for sure, especially in these fields. So I think a big thing is just to try to remain resilient and persevere and remember why you're interested in this. And again, talking with people and um, getting mentors to kind of support you along that way and encourage you and just enable you to take on this career that you want to. Um,
Yeah, no, that makes sense. I mean, I'm not going to sit here and tell you that I passed every class with flying colors and got perfect scores because A's are great in college, but A's can be stretched far and few in between. So I got some B's and, things like that. So no big deal, right? But if you want this type of field and you are exploratory in that way, I mean, STEM can be so rewarding and so much fun. Sometimes it's not about the money. Money's good, but sometimes it's not about the money. It's about the circumstances of how it thrives, your discovery traits and things like this. So I think that is great insight. Um, what common misconceptions about STEAM careers would you like to address for new students, current students, students that might go back to school, students that don't plan on being students again but just want to hear it? What are some misconceptions that you want to address or clear up?
Yeah, I guess one that I've had in the past was about whether to go to a grad school or not, or if undergrad is just enough, and about kind of getting jobs after you get your education. And I think it depends. Definitely in biology, there are careers out there. There's lots of employability options. Maybe you can work in a lab as a technician. And there are other opportunities, science communication, for instance, that you can explore. But then also there's graduate education as well. And I think that that can depend. I think definitely going into college, at least for me, when you're surrounded by professors, a lot of time they'll say you should become a professor, or if you're surrounded by a
Yep.
certain group of people, they'll say you should become this person.
Right.
So I think it's great to have a diversity of perspectives, or try to surround yourself with the kind of people you want to become, or talk with the people that you want to be in their shoes someday. So I think that's a big thing is that I was told a lot, you should become a professor, stay in academia, but I think I want to go into industry. So you don't might not necessarily need to go to grad school for that, but also you can do that if you want more experience. So I think it's important to um, listen to yourself and what you want to get out of that. That there are many options, that it's not limited, that you can explore a lot, and to get different perspectives, I think.
Yeah, absolutely. And just for audience, like, I guess, insight, right? I was 27 years old, finished a double master's program, and went right into teaching. But I was also still at Johnson Space Center. So
Mm.
I was teaching in the evenings, in college, undergrad, but I was also still working my regular 9 to 5. So it is, and there's an ability to do it. But unfortunately for for your circumstance that you're explaining, like one person will tell you go here and the other person, I
Yeah.
decided to merge the two and I was a glutton for
Right.
punishment. But but it did work out because I learned a lot about myself by teaching the things that I was supposed to retain in the first place. How can I be a better scientist if I can't regurgitate and teach somebody else
Mhm.
how to do the exact thing that I
Right.
am doing? So I learned a lot from that. So if anybody here is interested in going the professorship route, you don't have to have a PhD to be a professor. You could start off at a undergrad level. Usually, what they need is about 18 to 20 credit hours in grad level studies in the specific area that you want to teach. And if you talk to the right professors or to the right department chairs in some of the community colleges in your area, then likelihood of you getting access to be able to do at least one semester is very, very high. So if you think that you can't be a professor without having a PhD and 90 years of educational background, it's not impossible. So I'm here to definitely tell you that Ruth is definitely on to something if you decide your mentor wants you to go one way or the other. And speaking of mentorships, we got one more question. How important is mentorship in your field? And what tips do you have for finding and working with mentors? Because everybody's got a way, but what are your tips and tricks?
Yeah, I think mentorship is really, really important in the field, although they don't necessarily need to be in your same subject area. I had one who was a aerospace engineer, another who was an astrophysicist at Yale, and then another one did space policy. So I think that mentors are valuable in all of their forms and shapes, um, and that they can provide. I think also an important thing to know going into mentorship programs is kind of your mindset and what you want to get out of it. Um, and that's maybe if you want specific technical expertise or I want the specific job, then maybe the field of your mentor does matter. But oftentimes, all your mentors can give you valuable life advice, networking advice, professional advice. And also, I think besides just professionally, they just are kind of a support group for you. And sometimes maybe you'll even go meet up somewhere or, just catch up, even if maybe they're not an active mentor anymore. So I think that it's very valuable to make these connections, but also if you know you want to go one specific route, I think it's great to try to have mentors in like kind of what I mentioned before in the shoes that you want to be in. I think
Yeah.
that's learning about their path and advice is like that's just kind of the way to go to what you want to, although there's many paths, but I think just getting these different perspectives can help shape you into a better person, well-rounded person. And I think it can be difficult finding mentors or connecting, um, just emailing them out of the blue without that initial connection. So that's where I encourage you to get out there, to get engaged, whether it's going to events like this or going to conferences, um, doing competitions, hackathons, because that's where you meet
Yes.
people and you can meet potential mentors. Um, and then afterward, you can follow up with them and say, hello, it was nice meeting you at this event and talking about this thing, because I think there will be that connection and they'll know you, they'll have seen your face, know your name. So there's a high chance that they'll want to respond to you. So I think that having that initial connection is very valuable. Um,
Yeah, I mean, and you brought up hackathons. Just for the audience, the perception is that hackathons is just for coders and people that know how to hack networks and systems and things like that, but absolutely not. There's a very extended surface when it comes to hackathons. So definitely look into some and see if you want to get into things like that. And if you need help looking for any of these things, definitely reach out to AWISDC at AWISDC at gmail.com, and we will definitely help you get aligned with some people. And if you just have that little bit of a tinge of fear where you don't really want to reach out to somebody. If you think that they're scientifically involved with us, reach out to us and we will definitely reach out to them on your behalf and say, hey, would you mind taking on a mentor for, X, Y, and Z, whatever you're looking to do. And we will definitely help, solidify that engagement for you so that you feel more apt to doing it on your own in the future. So I think that's awesome information, awesome takeaways from Ruth, especially with some of us that might not be that. I know I'm an introverted extrovert, so I'm not always apt to going to talk to just random people, but I'll do it just in case. I might miss out on an opportunity for a really meaningful engagement. Um, so as we conclude our extremely captivating discussion on astrobiology and mathematical sciences, I'd like to invite Ruth to share her parting thoughts. Ruth, reflecting on our dialogue today, whether it been on or off script, because I know I caught you with a couple of freebies for the overall knowledge for everybody. From engaging in undergraduate science research to communicating complex scientific ideas and your impact as a future leader in space exploration, because that is what we're talking into existence, ma'am. Can you share with us, our audience, a final takeaway?
Yeah, I think I want to just thank you all for coming and listening. I really enjoy being here and sharing my experiences, and I'm hoping that me sharing about my thoughts, my experiences, I hope that that can inspire you or encourage you, or maybe kind of give you a new seed of thought of something you hadn't heard of before, thought about before, because I'm very passionate about, as you were talking about, kind of passing the torch and sharing this knowledge with others. So I hope that you've learned about scholarships, about analog missions, about astrobiology and math, and about mentorships, about just kind of growing and getting more involved with science and your STEM career. And I want to thank you for planning and coordinating this and inviting me. And this has been a wonderful time. Thank you.
Yes, absolutely. And I mean, you have no idea. Like, I have fun. As soon as I started hearing about astrobiology and like the whole space mechanics and like mathematics, like I go in an explosive manner, almost like a 6 billion year old star over here. So yeah, that's what I do. So as we bring our enlightening session to a close, I want to extend my deepest, most sincerest, heartfelt thanks to Ruth for her invaluable contributions and insights shared with us today, especially her perspectives on astrobiology, applied mathematics, and communication science. Those are three big things that are all tied in together, and they're also separated. To our audience, we trust that today's conversation has not only been illuminating like a star 6 billion years away, but the exciting intersections of space exploration and mathematical models in our contemporary landscape, but also inspiring interest in these dynamic fields, encouraging you to either embark on this exciting journey or to navigate your existing course with renewed passion and insight. So please look for our next guest in STEAM speaker series. I'm not going to tell you who it is, because I never tell you who it is, but I want you to just pay attention. We do have one coming up in about a week. So definitely stay tuned, subscribe to our channel, like this, comment. If you comment and you have a question in the comments, we will definitely, respond back. So definitely ask us questions if you have any. Thank you for tuning in and exploring the vast frontiers of space and science, as well as pushing the boundaries of knowledge and inclusivity. I am Ambericent Cornett alongside our extremely calculated guest and new AWIS DC analog astronaut, Ruth. And together we're empowering women in science, one discovery at a time. So live long and prosper. I know, Star Trek, I'm sorry. Bye.